Welcome back. It's been a while since updates. We've just got a Clio 4 here that we've finally finished the package on. It's been a long time coming. We've had to work through a whole lot of different issues with the car. We've finally got it to a point where we send off a Motec to registers and it'll be available next week. Basically it references all of the factory systems. You can see down here at the moment it's got a couple of diagnostics. We've got dyno switch override because basically we're on the dyno and the rear wheels don't turn and it throws an ABS error. You can kind of see this up here. You can see the ABS error is active. Just going to turn the fuel pumps on. So start the car now. All that stuff's kind of active. You can see it's running there. It's been quite a long-winded process just because it's a very complicated system. It's completely different to what the Clio 3 was. It's similar to the Megane 3, but it's got a whole heap of other features that we had to be able to get to work just because it's got the EDC gearbox. The EDC gearbox, TCU, or the transmission control unit, it's the boss. It dictates how everything works. It dictates the upshift, the downshift, all the rest of the stuff. The Motec system has to read all these values and comply with what the TDC unit wants. What you would find is one of the biggest things that we came across was the launch control function. Now the EDC launch had a whole lot of different parameters where it wouldn't send the message out. So we'd read the message as it comes out of the CAN bus, and that's what would dictate the launch. But then we also thought, when we went through all of it, if you actually have enough brake pressure on place, then you can actually get it so it still will do the launch without the EDC launch switch coming out of the transmission. But you have to hold pressure. Basically it won't try and put drive into it until you get to about the 2500 RPM mark. The only limiting factor in this is as the clutch gets hot, if you've done a few launches, then it does start to drag, which is one of the parameters why the EDC launch in the factory unit won't turn on. So what we're going to do now is we'll just try and do this launch thing. We're just going to put it into bike. You can configure it in all different modes. We'll just put it in sport. So if you look at this here, I'm just going to pour the throttle, see what we get. Okay, so we'll just turn that off then. What you see is we did get into the launch mode. It was all kind of inactive and we made like about 11 pounds of boost. You can see there our manifold pressure. It was about 11. If we had held it, it would have made a little bit more, but we just didn't really want to drag it too much. If you look here, you can see that we've got our launch control strategy in the Motec. We come up to, or down to, our launch control stationary stuff. You'll see that we're enabled, that's all working. If we come up to our launch section, launch control stationary is operational, and if we come up to boost, you'll also see all our boost aim stuff. It's launch stationary. Basically from where we started to where we finished, 13.58. It's about 3 to 4 seconds for us to get up on the boost, so it's not terrible. While we're here, we might just run through a few gears, just so you can see it shifts gears and everything else. to understand is we're actually running this on dyno, so there's no real load, which is why it struggles with a couple of downshifts, because we don't have the car's actual physical mass as against the deceleration force coming into play. So now we're just in normal mode. Once again, you can see it upshifts and downshifts. All the shift does works fine. So these are all the switches that we receive out of the factory CAN bus. The biggest thing that we maybe struggle with a little bit from a couple of different variations, like the first thing was we had to get the torque monitoring correct. Our first variation on this file, we didn't have that correct, and the shifts were all too harsh up and down. We had a really good customer from Queensland in Australia who sent us a car down to do a Nissan Pulsar SSS with C12, which has the same engine but a manual gearbox, so that let us map all the torque numbers so we get our values correct. And then with the car we had here, we put all of that into it, but we still worked out that even once the clutch was re-engaged after a gear shift, because we could make so much more torque than what the factory system made, we could induce slip. So then we had to put some secondary protocols in place to be able to control that slip, which we've done. So if we come up here in EDC gearbox, these are all our values. We calculate slip, we calculate torque, we calculate all the rest of it, but we have a slip control section. So when you come to the slip control section, as you can see, we have our RPMs and everything else, but we have a boost limit control and we have a fade out from when it gets activated to when it goes back to no activation. We have a throttle limit control that does the same stuff, ignition cut control and ignition timing. What we found is the boost limit control, it's probably it's not like an immediate effect, it's more a gradual long-term effect. A throttle limit effect, that tends to be more an immediate effect. Ignition cut control, that's an instant effect. Ignition timing control, it's more a long-term effect. So these are the tools you have to be able to control the clutch slip. It works incredibly effectively. We've been able to take it from a situation where we had 200 or 300 RPM of slip down to the point where we virtually had nothing. So that part of it we're all pretty happy with. It all works really well. Some of the other stuff we have in here, we have the cluster speed display correction. There's a value that gets sent out from the ABS, which is what the cluster speed displays, or the dash displays. Normally these things are about 10% high. If you really want to, you can correct this number so that it's actual exactly what your wheel speed number is. You can do the same thing for the cruise, so that the cruise number is actually what you set it at rather than what the wheel speed number is, because the Motec does want to display like a vehicle speed number that you set it to, not so much the cluster speed. So you may need to correct that. That also happens for the speed limit function, because all those functions work within the factory system. We just have a little bit of a look here. What we're going to do now is we'll just turn the sport function on. We'll just turn that back off again. Then you can see we have our speed limit and our cruise control functions. The cruise and everything else works, as does the air conditioning and everything else within the car. So it's like it's a total system. Basically everything happens with our oil switch replacement that you can see here. Basically, if you put a pressure sensor in and then you wire one of the outputs to where the pressure sensor was, the system will function like normal. So normally, if you, like most of the switches, are rated about 7 psi. If there's less than 7 psi, your oil pressure warning on the dash will illuminate. With this, you can configure it so that it might be 30 psi at 3000, it might be 40 psi at 4000. You can configure different levels of when the switch is going to activate, and then the ECU will activate it for you. We have the factory purge valve, which is controlled. It reads all the RS modes. If you have the RS monitor, it can do a whole heap of functions with that. Sport mode, it will increase the RPM just like the factory does when you put in sport mode. The other function we've got is if you do run flex, you can have it so you can change the tachometer value against the switch. So if you pull the handbrake on when you're stationary and you've got 60% of ethanol, the RPM will display 3000. If you've got 80% of ethanol, it will display 4000 RPM. It just gives you a little bit of an idea about what your flex fuel number is at that point, because the system is completely flex fuel tunable. So it's just kind of the stuff that we've written into the program, so you're happy with it. All the air conditioning stuff works exactly like normal. It sends all the messages back on the CAN bus, all the start features and everything else. They're all contained. We can have a crackle overrun feature, which gives you the pops and bangs on overrun. We can give you ghost cam, so basically if you pull up to idle, it'll idle like a top fueler. Like it's got massive cams in it. You can turn that on and off by a switch, which is the ghost cam function that you can see there. If you put a GPS unit on it, it will, and your car is a track car, it'll give you extensive log files and lap times that you can overlay and compare for all the messages. If you've got a PDM in the car, it'll do all the stuff with that. There's rain light, there's a whole lot of other functions with all of that. It will calculate torque for you and calculated power. It'll do a whole lot of stuff with that. The other nice function is if you're in a country where you can't get E85, you can run on water meth and it integrates with the system. It'll throw warnings if something goes wrong. So if you're like the water meth number is too low, whatever else, it'll throw all that kind of stuff. It'll tune like tune the fuel, and it will tune the timing when the system's active. It has all those capacities within it. If you are going to run E85, you can run flex, put a flex fuel sensor into it. If you buy one of the CNC manifolds that we've worked extensively with them on, you can actually run secondary port injectors as well as the primaries, which kind of puts you back to where that GR Yaris is, and they make massive amounts of power, so it's not to be sneezed at. Like there's some gains there that you can actually make. These are our cruise control functions and everything else that we have available. But basically, that's where the system is. It has anti-lag as well that we can enable, which is incredibly effective. It's like WRC level anti-lag that we can instigate into these engines. Everything's available. This kit will be available next week. This car's running on it. We have another kit that we need to send off as well for an immediate order. We've got another order that's pending at the moment, which is really close, that we'll have to do some other stuff on. So there'll be a few of these kits out in the marketplace. At the moment, we do need a donor ECU so we can get the header board out of it, but we are trying to source the header boards. Once we can source the header board, then we can have a PCB based header board adapter, which will be a whole heap neater, but it's finding the header boards that works for these ECUs. So if you've got a link, please send it to us. But this is where we're at. This car's getting a PDM now because it is a race car. Once the PDM is finished, then the next exciting thing we have is that we have a Megane 4 RS and RS 280, which will be a next program, which will actually come onto the dyno next week. We'll be working through that program, which will be a little bit easier. Once we finish with that program, we'll probably do the automatic if we can get a donor card, just so we have that one sealed off. And all you people out there with an Alpine A110, please don't feel like we're ignoring you. The Alpine A110 program is incredibly similar to this Clio 4 program, like the CAN bus. We've already scanned one. It's incredibly similar. It's very much the same. We could make a program incredibly quickly for one of those, but we just need a donor card to be able to test it on, and so that's our limiting factor right at this point in time. And if you're overseas, like, please don't discount the fact that we can do it for you. We can work with you overseas. We'll just need you to do some CAN bus scanning for us over there, but we can send you over a tool to be able to make that happen. But that's the next thing. The other exciting thing we've got in the program is that we have some Megane 3 hybrid turbos. We're actually going to run a whole heap of tests on a hybrid, like on Megane 3, with various turbos on it, so you can see the gains. And we have a manifold that we've developed that we'll be able to put these on. It's a dual drill manifold, so you'll be able to run that, and this is going to be able to let us have different AR ratios exhaust housings, which is really the limiting factor. The exhaust back pressure is what really kills Megane 3, and if we can reduce that, we'll have big steps forward, and that's why we've got the bigger AR rehousing. But that's what we're working towards. Thanks for watching. Appreciate you taking the time. Please check back again. We will try to have more regular updates. Thanks for watching once again. Thank you.